So what is a tag anyway? A tag is something, either an injection target or an identifier, that takes plain old text and transforms it into something a little more dynamic. This can be done by adding special characters into a string, which can then be processed to change the appearance of whatever it's affecting. In rich text, the symbol B identifies bold font. And we can enable the use of these tags by enabling rich text in the UI text component, but by default it's already enabled. So if we change this B to an I, then rich text will switch from bold text to italics. And it's that simple, just add your tags into the text, and you've got some life into an otherwise static string. Now there are a few tags supported by Unity's built-in text system. There's B for boldness, I for italics, color for color, and size for font size. So if we have a special instruction, name, or location that's being mentioned in our text, it might be a good idea to make it stand out with a different color. The easiest way is by calling the name of the color you want, such as green in this case. But in order to make any tag work, it needs to both start and terminate. And to terminate a tag, simply add a backslash preceding the name of the tag, and this creates a segment within your text that's changed depending on the tags in use. Some common colors would be green and red, and blue and yellow, but if you want some specific colors, then you'll need to know the hexadecimal value of that color. Fortunately, Unity had our best interests in mind, so you only have to open the color wheel and it'll show you the hexadecimal value down at the very bottom. Whatever the value, when you assign it in the color tag, it must be preceded by a hashtag symbol, unless you're using the name. But we also need to bear in mind that in order for tags to work, they need to be terminated in the proper order. In this string, a tag for bold is opened, then italics is closed, and then bold is closed. If I open italics after bold, but then close bold before italics, then neither one would work. So the order of termination is absolutely important here. Here's the rule of thumb. The first tag opened is the last tag closed, and the last opened is the first closed. But this only applies when tags are started inside of one or more tagged areas of text. Okay, now, so if we're all on the same page, then we understand how to use rich text tags. But since tags only take effect once they're completed in their entirety, we have a bit of a complication seeing as how we're generating text with a character-by-character style. Sadly, this means our tags are going to be generated like the rest of the dialogue, character by character, and then disappearing and taking effect once they're finished. As I slow down, you can actually see just how nasty this really looks. You see how this presents us with a major visual impediment. So how can we handle this so that the tags apply as dialogue is being generated? We're going to do this using a method called encapsulation and sub-encapsulation. That way we encapsulate the text being generated within the appropriate tag areas, resulting in a smooth and beautiful finish. Basically, it looks like this. As the text is formed, the encapsulating tags are automatically applied both before and after the stream of characters. Sub-encapsulation occurs when a tag is contained within another tag, so there will be different effects inside of one area that need to be handled by parent and child encapsulators. So this is how it'll work. We're going to examine a string, and by this point we know that all tags are going to be inside of our alligator brackets, so those are good characters to look for. In fact, we'll split this string by both of those characters, and that leaves us with 3 words. But we remember that blow was split by the bold tag, so we'll relate them back to it as the starting and ending tags. So now we can go through each section and build it character by character, but when we come to the word blow, we build each character while encapsulating it between the 2 tags. Now when it comes to sub-encapsulation, we find again that the phrase really gonna is encapsulated by the italic tag, but then inside of it, blow is encapsulated by the bold tag. That makes it a sub-encapsulator, and any sub-encapsulator must not only encapsulate its text with its own tags, but also its containers tags. And once we've isolated all of the tags, we can generate each section, sandwiching them between their encapsulators. So now that we've got an idea of what we're going to do, we need to create a class to handle this text generation. Currently the dialogue system is responsible for building text, but after this video it won't be. I'll start by creating a new script called Text Architect. And it's not going to be a mono behavior because this won't be attached to any game objects. Text Architect is going to be a class we can call as a variable type. Now this will generate text, so we're going to want a string variable to store the text as it's being created. Make a private string because we don't want to edit the value outside of the architect. But we will want to retrieve it publicly, so make a retrieval variable for that instead. We also want to store a few variables the architect will need in order to function properly. These will include the target text, the intended outcome string, and in case we use additive text, we want a pretext field, which will be the text that's appended before construction of the target text. Now, how many characters do we want to generate per frame? Make an integer for that, and by default, let's just say 1. Additionally, make a float for the generation speed, and this will just be the delay between characters being added into the text. A value of 0.01 will be multiplied by this speed to determine the amount of delay in seconds, so a higher number means a longer delay. I'll make it range from 1 to 60 since it should never be quicker than 1 frame. Now you can optionally make a boolean as to whether to use encapsulation or not. Remember that encapsulation applies tag effects as the text is being generated. Then make a public boolean called skip that'll allow us to generate text at a much faster rate. Now when we create the new text architect, we want to pass in some information and have it start working immediately. So let's create an initialization call. We'll want to pass in whatever it is we want to generate, so that's the target text. And that's really the only variable we're required to input, but let's add some options like the pretext in case this is additive. Now add how many characters are generated per frame with a default of 1, and the delay between characters at another default of 1. And lastly, I'll put in an option to disable encapsulation if ever I wanted to do that. Alright, cool, so now we can create architects, but inside the function we need to assign the values, and since they are of the same names as the variables they belong to, we need to proceed our assignments using the keyword this. Alright, now how do you think we're going to manage the build process? We'll be doing that with the coroutine. So let's do my usual process of making a private reference to the active coroutine and a public boolean to whether it's active or not. The coroutine will be called build process, and the boolean will just be called isConstructing, so it only returns true if the build process is not null. So if we access isConstructing from outside of the class and it's true, then we know the architect is busy building our text, and we can yield and do whatever. Now make the actual coroutine called construction. And in our initialization, set the build process to be a new construction process. Again, just like our character, the architect is not a mono behavior, so we can't run its own coroutines. Let's make the dialog systems instance handle any text generations instead. Now, before we move on, we need to create a very short class to help out our architect. This class will be called a tag manager, whose sole job is to split strings into arrays based on the presence of tags. And it'll also handle special tag injections, but we'll focus on that in a later video. For now, just remove the start and update and create a static function to split our strings, and make sure that it returns a string array. The parameter will be the string we want to split, and inside just return and split it using a character array containing both of the alligator brackets. Now back in construction, we can continue. The first thing we want to do is monitor how many characters have been built in this frame, so we can make sure we use our speed variable. Second, we want to gather all of the different parts of text we need to build, isolating the actual text from the tags. And since encapsulation is an option for me, I'll check that first before I try to split it. If I do encapsulate, then I'll tell Tag Manager to split my string. Otherwise, I just use the entire text as a single part. Additive text is true if pretext is not an empty string, so I need to assign the current text to equal the pretext. That way it'll already be displayed before any text generations begin. Now this is important. We need a storage variable just for the currently displayed text, because when we encapsulate text within tags, we need to do some appending for every character in the string. And it would be much easier if we separate the current text from the encapsulated text. So I'm going to make another string variant of current text, and this will just represent what's currently displayed prior to an encapsulation build sequence. Now we can begin the generation loop. Increment through each segment of our string array, which will give us the text and tags as separate items. Store the current segment locally within a string called section. Now we need to find out if this is a tag or not. Since we split the string by the alligator brackets which identify a tag, we can't look for those in a section to determine what's a tag and what isn't. But there's a nifty little trick here. Regardless of if our text started with a tag or not before the split, the first item will always either be empty or text that just isn't a tag. So index 0 is never a tag, and index 1 will always be a tag, then just alternate back and forth. So really, if we have any tags to consider, they'll be odd indexed. So make a boolean called isAtag and set it to true if the current index in the loop is odd. You can find this out by using this formula. Now, if this section is a tag and we use encapsulation, then we need to generate it using a special technique. If it's not, then we generate it like we've done in the current dialog system setup, character by character, and that's it. So let's take the easy route first and build the string that isn't tagged. Loop through every character in the string and append it to the current text field. And just like that. And now let's not forget to calculate this into generations per frame, since we should be limited to a certain amount. And if we're skipping, then I think we should ignore the limit and go with something very fast, like 5. This will be our max runs per frame, and after reaching this number, we have to yield for a certain time limit. So once we reach the maximum runs, reset the current runs for the next frame to 0, and yield for the frame if we're skipping. If we're not, then yield for a frame multiplied by our speed. There, and that takes care of non-tagged text. But if text is tagged, then we need to start looking at encapsulators and sub-encapsulators to make sure our text is built nicely. Start by assigning our storage string as the current text before encapsulation begins. And we'll have to come back to this. For now, after the entire loop through all the sections is finished, assign the build process as null, so that way the architect will finish construction. Now we have to make the encapsulators. At the bottom of the architect, make a private class for encapsulated text. Then we need 4 strings, one for the tag that precedes the text, and one for the tag that precedes it. This gives us our open and termination points. Next we need the current text and the target text. This gives us our build string and ending target. Now we need a way to see the current final product of the encapsulator, and this will be our display text, and that's simply the current text encapsulated by its tags. Let's have a public and private variant, so that way we can only edit from within the encapsulator. Alright, so encapsulators are going to be a little smarter than just worrying about themselves. They need to finish their own text and then move on to see if there are more tags within itself. That means it needs the entire array of dialogue and tags so it can analyze what comes after its own target. And that also means it's going to need a reference to the current progress within that array and update when any changes are made. Then we want a boolean to identify as true once this encapsulator has finished all of its text and sub-encapsulators. Set it to false by default, and again make it publicly reference a private version so it can only be changed from within the encapsulator. Now let's make an initialization call so we can create our first encapsulation. Its first parameter should be the tag, then we need the complete array of dialogue and tags. And lastly, we need the current progress in that array. And just assign it like we did for the architect. Make sure to use the keyword this if they're named the same as the variables. Since target text is not an option to pass in, our encapsulator needs to get its target automatically. It can only do this if there's an item after it, which there should be, but I'm just adding this check for error mitigation. So we need to get the next part in the array. When an encapsulator is created, the array index is the index of the tag itself, so we need to increment that by 1 to find the next dialogue segment. Now we increment the current progress in the array, so we move from the tag to the target text. Now generate the ending tag so that it'll terminate the encapsulator. Make a separate function to do this for us, and call it above. Only don't use an assignment like this, I just have to come back and fix it later. Instead, just call the function, because that's going to create it automatically. Remember that a tag terminator is just the name of the starting tag with a backslash before it, so all we have to do is set the ending tag to the starting tag with a backslash. First, remove the alligator brackets. Then, since some tags take in values like color and size, if there's an equals symbol in it, split it and get the name that's on the left side. And since tag will be isolated, we need to format its name to include the brackets and backslash. And that gets us all the information we need to start a process. Every process made by an encapsulator is called a step. So make a function called step, which will be called by the architect to build the string. This function needs a return value of a boolean to indicate a successful step. Otherwise, there are certain points in text where we would experience delays because multiple steps have to be taken. First things first, if the encapsulator is finished, don't allow another step to take place. Return true immediately. And if a subencapsulator is present, then that one needs to finish first, so return the value of the subencapsulator step if it's not finished. Otherwise, a step has to be taken for this encapsulator. So if the current text is the target text, then we've finished, and we need to check to see if there's another encapsulator to add. Otherwise, there's still text to build, and we need to take the step in adding the next character. So add the next character in the target text. And then we need to update the text that's actually displayed from the encapsulator. So let's make that function now. Update display text should take in a string value, and this string is the display text of any existing subencapsulator. That way we have multiple levels incorporated into the final string. Format it to be the tag, then the current text, then any text passed in from a subencapsulator, and finally the final terminating tag. And if there's a parent encapsulator, update its display value as well, providing the string we just created. Then when we added the next character, update the display text afterward and return true, indicating a successful step was taken. Make sure that the provided string is blank, assuming that this is the lowest level encapsulator. And at the very bottom, return false as a last resort value to say that another step should be taken in this same frame. Now, if the text is equal to the target, then we need to check if there's another entry in the array after this. If there's not, then this is the end of the text and our encapsulator should mark itself as finished. If there's a preceding entry in the array, then we need to snag it and find out if it's a tag or not. Again, we just find tags based on the next index in the array if it's odd or not. Now, if the next part is a tag, then we need to figure out if it's the terminating tag or if it's a new starting tag. Format it to appear as a true tag, and then compare it to the ending tag of our encapsulator. If they match, then our encapsulator has reached its endpoint and should be marked as done. When this happens, we need to check if this is a subencapsulator. If this is the root encapsulator, then the encapsulation will fully end, but if it's a sub, then we need to add some information. If our encapsulator is not null, then this is a sub and we need to append the completed text of both the current and target text of the parent. Make the tag text by encapsulating the current text between the starting and ending tag. Then append it to the current and target text of the parent. Then we need to update the progress in the array by 2, since we need to bypass the current text as well as the tag we've just used to terminate the encapsulator. But let's do that through a function so we can make sure we update the encapsulator's progress as well as this one. An int called val will represent the increment desired. So increment the progress by val, and if we have an encapsulator, update its progress by the same value. This will carry the progress all the way from the lowest sub to the root. Now just use that method to update the progress by 2 if we've just terminated a sub-encapsulator. Alright, now we're almost done here. On the flip side, if a tag was not the terminating tag, then we hit a tag within a tag, and we need to create a sub-encapsulator. So all we need to pass in is the next part, which is our tag, but it has to be formatted as a tag for rich text. Then we pass in the array of dialog and tags, and the current array progress plus 1. Then make sure to set the encapsulator of the sub-encapsulator to this current instance, and update the current array progress by 1. Lastly, if the next part is not a tag and our encapsulator has not been terminated, then we've reached an extension of text that needs to be added to the final target of our current encapsulator. So that's all we need for the encapsulated text to function right, but now we need to head back to the text architect above and complete the construction sequence. So after storing the current text into a reset variable, we need to create our first root encapsulator. So define a new encapsulator saying encapsulator equals new encapsulated text, and pass in the formatted tag, as well as the array progress defined as A. And now if we say while encapsulation is not done, we'll loop until all of the text is finished. And I'm just going to scroll down here so I'm typing more in the center of the screen for you. Alright. During each loop, we need to call the next step in the tag process, but we'll also need to know if the step was successful, so assign the output of our encapsulator step into a boolean. And after a step is taken, this display of the encapsulator should have changed, so we need to update our current text as well. Set it to equal the stored current text plus the encapsulation display. This way we can keep reverting back to the original text and adding the tag text until it's finished. And if a step was taken, then we should increment the current runs during this frame and yield if necessary. Just copy the same sequence we coded down below to save yourself some time, and to end it all off we need to update the current progress to the encapsulator's progress, since they'll no longer match. But apparently I didn't make that value public. So back in encapsulated text, I want to make the array progress publicly retrievable. And now we can access the encapsulator's array progress. And of course I need to change this from a boolean to an integer. And where we define the tag and ending tag, current text and target text, make sure you assign each one as an empty string, or you'll wind up getting a null reference error. 3 guesses how I figured that one out. Alright, and now we can test it out. So I'm going to go through my usual routine and create a testing script, but the great thing about Text Architect is it's extremely easy to use. I need the UI namespace since I'll be displaying the text using a UI text component. Then I'll store the text as well as the architect, which I'll create an update on a key press. My text area is where I'll type what I want to be built. Setting the text area size will give me a better view in the editor when my text gets lengthy. So creating an architect is super easy, and it'll start building the text automatically. and I'll make it automatically create an architect on start. Then just update the text component's text to equal the current text of the architect. So now let me type something tagged in here. And start up the game. Okay, so we can see that the tags didn't show at all as the text was generated, which is good, but it looks like my tag text is duplicated for some reason. And you see here, we only have one tagged region, so the encapsulator's not duplicated, just the text inside. This is because I used the wrong variable when our encapsulated text is first created. We take the current array progress, and then we need to increment it so it moves past the first tag. The problem is, I incremented the value passed in instead of the encapsulator's variable. Make sure you precede the variable name with the keyword this if the variable and value are of the same name. And that fixes my problem, so now let's move on to cases that will require one or more sub-encapsulators. And we can see the effect of many encapsulators working together to produce some special text here. Now I want to test the additional parameters such as characters per frame, speed, and use encapsulation. So I'll set the speed to 15, that way our characters have a slower generation speed. This forces the text to generate slower and also lets us see the tag text with the full effects applied to each character as they're being added to the total string. And if I turn encapsulation off, then this is essentially how our text was processed before. But currently our dialogue system isn't using the architect, so anything generated by it isn't going to use encapsulation. So let's change that right now. I don't need the start function, so let me just delete that. Okay. Alright, now down here, we just start building the text on our own, but let's create a new text architect to do it for us. Call it architect and give it the target text of our desired speech. And let's take into account whether this is additive or not, by making the string either empty or equal to what's already on the screen. And give it to our architect. We don't need this anymore. We still want to keep the speaker name though. And user input is false, but right here, this needs to be a loop for as long as the architect is constructing the text. And we don't add anything, so let's delete that. What I do want to add is if I press the spacebar, I want to skip dialogue, or make it go faster, and we can do that just by setting the architect skip value to true. Now let's just set the speech text to equal the current text of the architect. But I think I want to make the architect into a variable outside of the function, because when I stop speaking, I'll want to stop the architect, and I'll need a reference in order to do that. So just define it beneath our coroutine, and then correct it down below. Alright, good. So let's do that now. Head up to stop speaking, and make sure the architect is terminated at the same time. Now let's make the stop function for the architect, and that should be the last thing we have to code for it. When we make this function, it's important that we check if it's running first by looking at our build process. Then use the dialogue system to stop it and set it to null. Good, and that takes care of stop speaking, so that will now work. And now we can update the display text to match the current text generated by the architect. And that now allows our dialogue system to use tags without the ugly side effects we had before. Okay, I gotta be honest with you guys, I hate going this long into tutorial videos. I like to keep it as short as possible, but we've got 2 small hiccups to address and then we're done. So bear with me, we're almost through. When we skip text or use multiple characters per frame, the text architect by itself has no issues, but the way we've set it up in the dialogue system cuts out the last few characters in every string. This is only because it's updated for as long as the architect is not finished, so we just have to make sure the speech text is updated once more after the architect is done. Because the architect will always finish its text unless you tell it to stop, just make sure that you always allow your strings or text to update with it. The second pickle is when we use additive text with the dialogue system. It appears to only keep track of our most current last string displayed, even though every entry I'm putting in is additive. The reason for this is our target speech needs to be updated within the speak method. Whenever we add, our speech text becomes the target speech, which is set in the coroutine to equal the most current dialogue on screen. The problem with that is it's not assigned correctly. We see that target speech simply becomes the desired speech, when in fact it should become the additive string, whether populated or empty, in addition to the desired text. But once again, if we do this, we also need to verify the correct input is provided to our architect, or we'll be seeing duplicates of everything. So make sure our target passed into the architect is the speech provided to the coroutine, and then the additive text is the additive string we made at the top. Only then will additive text work correctly in our dialogue system. So there you have it, that's all you guys need to know about using encapsulation for rich text tags. Eventually we'll get into tag injection where we replace phrases with variable values. But that's a little ways off and much quicker than what we did here. This video was pretty long, but we had a lot to cover, and I hope I explained everything well anyways. If I didn't, make sure you leave a comment in the description, and if anyone had trouble following along, you can check that for the finished code. And give me some feedback so maybe I can do something to make it a little easier to follow next time. And a lot of time and effort goes into making these videos, so if you liked it, please give the video a thumbs up and subscribe to the channel for what comes next. Until the next video, I wish you all a good night and good luck.